Hey guys, welcome back to my channel and welcome back to the series where we learn A2 maths together. So, today I'm going to be teaching you why radians make things easier. And I did that the wrong way around. How do radians make things easier? That is the title of today's video, and I'm going to be showing you kind of some formulas that there are formulas for without radians, but the radian formula is like 10 times easier, much easier to remember, much shorter, much quicker to put into your calculator. And it's all because of the fact that you can substitute theta equals 180 over pi and simplify it like that. So let's get into these formulas and do some worked examples. Let's turn. Okay. The first one is arc length. Arc length. What is an arc? Well, arc is a certain amount of circumference as well, and it's also like arc shaped, you know, mixed to like a part, like that's an arc, right? It could be an arc of like this circle here, but you know what I mean, that's an arc. So what if I actually draw out an arc? We'll go, you know, what is this shape? What do we think the formula may have already been before we convert to the new one? Hint, it's the same way we got what 1 radian was equal to. So, oh look at my pen running out. Well, okay, there is, we'll call this arc, there's radius, and there's theta. Give you a minute to think about what you think the formula might be. Okay, so our arc length formula is, let me actually just rub that out and convert to blue pen because that's nicer. Our arc length formula is theta over 360 times 2 pi r. It's a certain amount of circumference, and the certain amount, so there's circumference, and the certain amount is theta out of 360 degrees. Well, remember what I said we can make it easier because theta in radians equals 180 over pi. What happens if we substitute that with 180 over pi? So we have 180, it's just we're going to multiply it all in one step. 180 times 2 pi r over 360, and we're multiplying it by pi. Well, 180 times 2 already gives you 360. Pi gone. So our arc length is r theta. R is there, and we substitute in theta. R theta. As easy as that. Surprising, isn't it? Because obviously, as you see, whenever we put in theta in radians in the degrees format, you're left with r. But remember, you actually still have theta going into that. That's why the theta stays. You get r theta because theta is not equal to that. So it should really be like theta divided by thing, but you know, r theta, where theta is in radians. So that's a nice formula, isn't it? Instead of that long one. So arc length becomes r theta. Very nice, very simple. Okay, what about another one? What about area of a sector? Here's sector, there's number of degrees, there's radius. What is the area of that? Well, you know, pi r squared multiplied by theta out of 360. What a long, complicated formula. If we use this fact that theta equals 180 over pi. So, pi r squared 180 over 360 pi. Well, you can go. Cancel it down, you get a half. So r squared, a half. And we still have to multiply by theta because remember we put in theta, but we used the values of theta rather than what theta is. So theta goes in here, or if you don't like that way, you can just go for a half r squared theta. So let's rub that out and we'll write both of these new formulas down. If my rubbers would actually work, it would be even more helpful. Okay, so arc length equals r theta, nice and simple. Area of sector is equal to half r squared theta. Nice simple formulas. Nice shorter formulas. So how do we use this to do something? Well, let's take a baseball field. If our baseball field is this kind of shape, or the guy stands here and hits the ball like anywhere in this area, say that, so this is a quarter of a circle, by the way. We'll call it our right angle. Right angle is no longer 90 degrees. Right angle is pi over 2 degrees now. We're grown-up people. And we'll say that the radius of this circle that this comes from is 70 meters. What is the perimeter? What is the perimeter of this field? Well, don't forget to write in. Don't forget this part that we have our 140 meters, right? That is our two straight parts. And what's the arc length? Well, we know our arc length is r theta, so it's going to be, we'll call it L. L equals r theta. L equals 70. Theta is pi over 2, which is 35 pi. You could say 140 plus 35 pi, but if I type it into my calculator, 140 plus 35 pi, we get a nice, almost round. If we add both of these together, I'm going to add them, we get 249.96 meters. You could probably round that up to 250. But there we go. That is the perimeter of this quarter circle, using our new formulas, which are very easy as long as we make sure we're in radians. Okay, what about the area? Oh, my board is now going to be red. But you can't see that, so that's a good thing. Okay, what if we work out the area? The area, using our new formula, half r squared theta. Well, let's do it. Half times r squared, 70 squared, times pi over 2. 70 squared is going to be 4900, as far as I'm aware. Yeah, half 4900. When you divide that by 2, you get 2450. Divide it by 2 again, and you get 1225. So it's going to equal to 1225 pi, which is your answer. Meters squared, of course. But if you want to work that out, 1225 pi, your answer is going to be 3848.45 meters squared. So as you can see, kind of makes things a lot easier, doesn't it? So now let's go into the next thing, area of a segment. Now, a GCSE, or whatever you did before this, we call it GCSE, by the way. It's like you have to do all the bits of the calculations, when in reality, with radians, everything is so much easier. So let's draw our segment, There's the triangle, and there's our part of the triangle. We want to work out this part. Now, you probably worked it out as area of the segment minus area of the triangle, right? The triangle here is r. Let's just say it's a lot easier with radians. I'll just tell you what the formula is. It's obviously going to be area of this, which is half, or not pi. Pi doesn't even come into this anymore because pi is included in the radians part. Pi r squared theta minus the triangle formula. And if you think about it, it's going to be the area of a triangle using the sine rule. So that's half AB sine theta, right? But remember the fact that A and B are the same. So it's going to be half AB, which we can change to r squared theta. Now, sorry, not just theta. How dare I forget half r squared sine theta. Now, you can, if this is all you have to work out, you can simplify this to simply half r squared theta minus sine theta, where both in radians, of course. That's just another thing, you can use that if you want. If you don't need to, don't. But if it's literally just work out the area of the segment, there's your formula. A very nice, easy formula actually. Just half r squared theta minus sine theta. But this is your main one because it's area of whole thing minus area of triangle. But let's do an example. So find is like you can literally just get a question being like find the area. So let's draw out our way. Here's our shape. Looks like an ice cream cone. Okay. Find the area of the segment created by a circle radius 8 and subtended from the angle of 2 radians. Subtended just means like out from. Yes. Created by sector, angle 2 radians with length 8 centimeters we'll go for. Okay. So we want to find the area of this using this formula, but because it's just find the area, you can use my simplified formula, which is going to be half. Ignore the fact that, you know. Okay, half. Brackets, why no? Okay, it's going to be half r squared, theta minus sine theta. It just saves you typing stuff into your calculator, so it's going to be r squared 64 divided by 32. 32. So it's 2 minus sine 2. Fun fact, you can approximate sine 2 as 2, but because it's in radians, but it's not small enough really to get a good approximation. So if I said 2 minus sine 2, am I in radians? 2 minus sine 2 gives me 1.09. And then multiply that by 32, you get 34.9 centimeters squared. And it's literally as simple as that. Or you could go the long way and go half of 32 times 2 minus half of 32 times sine 2. But you can work out which one for yourself you think is shorter and easier. This is what I think is quicker, yes. But by the way, fun fact, for small angles, you can approximate. So for example, if it was like sine of 0.1 radians, sine of 0.1 is going to be like pretty much 0.1. Let me see, can you see that in the calculator? Sine of 0.1 equals 0.099. Yet. You can see it's kind of accurate. That's just a fun fact. But only if they're very small, like you can see that there's already a big error in that anyway. But radians make it easier. They do. A lot of the formulas are more simplified if you just learn, like you sometimes just have to learn them all, or you can convert from the ones you know. But it does make things easier, and I really appreciate that from the radians. So thank you, radians. That is all I have time for today. If you like this, if you found this helpful, like, subscribe, comment down below what topic we'll go on to next. I know what topic we're going on to next, but you don't. But if there's any topics you want me to do and I've done them before, I will try and do something. But thank you for watching, and I'll see you again next time. Bye.